Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE May-June Series 2019 Paper 42. So this is one of the longer papers, the 2.5-hour paper here. So let's just jump right into it. Again, focus on the thinking process of how to solve so that you can figure it out yourself in future papers and not just filling it in to get the answer. You want to learn how to set it up and think it through. So number one here, the price of a newspaper increased from 97 cents to $1.13. Calculate the percentage increase. So if you've been watching my videos, we've seen this question type show up just about every test set. So we have an increase, so that means we need to subtract the highest minus the lowest, means it increased by 16 cents. And then percentage increase means we're going to divide that 16 cents by the original cost, 0.97, and we get 0.1649. And since we want it as a percent, we move that decimal place over twice. And we also want three significant figures, making it 16.5%. Then on the next part, we have ratios. One day, the newspaper had 60 pages of news and advertisements. So 60 is the total, and the two different sections are news and advertisements. The ratio of news to advertisements is 5:7, meaning the total of the sections is 12, or the total of the ratio is 12. Calculate the number of pages of advertisement. So the advertisement part of the ratio is the 7, and the total is 12. So 7 to 12 equals X, which is our total pages of advertisement, over the total number of pages. So 7 to 12 is from the ratio of advertisement to total, and then X is the advertisements in the newspaper over 60 total pages. Cross multiply, you get 420 equals 12x. Solve for x, you get 35. So 35 is the number of pages of advertisements. Now it says write the number of pages of advertisements as a percentage of the pages of news. So we need to find out how many pages of news there are. Well, if there's a total of 60 pages and 35 of them are advertisement, that leaves us with 25 pages for news. And if we write it as a percent of news, that's 35 advertisement over 25 news equals 1.4. Again, change it to a percent by moving the decimal over twice, so you get 140%. Letter C, on holiday, Maria paid 2.25 euros for the newspaper when the exchange rate was $1 to 0.9416 euros. At home, Maria paid $1.13 for the newspaper. Calculate the difference in price. Give your answer in dollars to the nearest cent. Well, we need to convert our euros to dollars. So 2.25 times 1 to 0.9416. We want to put the euros on the bottom so that the euros cancel with the euros of the 2.25. I should have put an E here for euros. I didn't. And I should have put a dollar sign on top for dollars. But we want euros to cancel, so we put euros on the bottom, dollars on top. When you multiply this out, you get $2.39 minus the $1.13 gives you $1.26 difference between those newspapers. Letter D, the number of newspapers sold decreases exponentially. So remember, when you're working with exponential, you use your compound interest formula, and here it's decreasing by X% over a 21-year period, and it goes from 1,763,000 down to 58,000. So the 58,000 is our amount after time. The 1,763,000 is the beginning or original amount. Then we have our 1 representing the original 100%, and it decreases by X percent. Again, in the formula, you need to put it as a decimal. And I prefer to use decimals instead of putting it over 100, but that depends on how your teacher has taught you. So I just move the decimal over twice, make it 0.0x, and the time, which is the exponent, is 21 years. So the first thing we want to do is we want to divide both sides by the 1,763,000, and that gives us 0.03289. Then we want to 21st root both sides to get rid of that 21 exponent. You can do it two different ways. You can either do a root with a 21 as your index number, or you can actually raise it to an exponent with 1 over 21 as your exponent, and that will cancel, either way will cancel out this 21 here. So when you do that, you get 0.8499 on the left. The 21 is canceled on the right, leaving you 1 minus 0.0x. When you arrange it for 0.0x to be positive, subtract the 0.8499 to the other side, you get 0.0x equals 0.15. Move the decimal over twice so that x is now our percent, and you get 15%. Letter E, every page in the newspaper is a rectangle measuring 43 by 28 centimeters, both correct to the nearest centimeter. Calculate the upper bound of the area of a page. Again, remember when you're working with lower and upper bounds, you usually have two layers that you're going to have to work with. The first layer are your initial measurements. That's the 43 and 28. So you want to find the upper and lower bound of each of those. So our 43 is between 42.5 and 43.5. And every time I have a student ask, why 43.5? 42.5 rounds up to 43, but 43.5 rounds up to 44, not down to 43. The thing is this, when you're writing this as a bounds, in other words, let's say you put a little x right here in the middle, your x would be greater than or equal to the 42.5 and less than but not equal to the 43.5, but you still write the 43.5 because it includes 43.4999999. Okay, so you still write it even though technically it's not included if you were to write it in boundaries. So for the 28, 27.5 to 28.5, we're doing upper bounds, which uses your upper values. Well, this is where you have to look at the second layer. The second layer is your formula. Since it's area, area just multiplies width times length. And in order to get the maximum area, of course, you want to multiply those higher values. So again, the first layer is your individual measurements. Then the second layer is your formula. So you're going to have to figure out which of those measurement values that you want to use to get the upper bound for your formula. So sometimes you use both upper, sometimes both lower, sometimes one of each. It depends on what the formula is. You're going to have to figure that out as to which combination in this case gives you the upper bound or the maximum value. So for area, since it's multiply, you want to multiply the larger values and you get 1,239.75. Now you might say, well, what about the three significant figures? Why don't you put 1,240? Well, because in this case, when you multiply it, this is an exact value. Your three significant figures comes into play when the decimal runs off the end of your calculator and you have to round it. You'll round it to three significant figures. In this case, it's an exact value. Even though there's a lot of numbers there, it's still an exact value, so you want to include all of them. Moving on to number 2, we have this uh, diagram involving angles. Says AC is parallel to FBD, and you can see that with these little arrows. That's your parallel indicator. You also see an isosceles triangle CB, oh, sorry, CBE is a straight line. It's your ABC right here is an isosceles triangle. You can see that with these little hash marks or tick marks here. These little tick marks show you that these two sides are the same, making it an isosceles triangle. Find the value of x, which is down here. The only given value is the 26, so we have to figure out how this 26 helps us to work our way down to find the x. Well, one of the things that you have here is parallel lines cut by a transversal. A transversal is just a line that cuts through both of your parallel lines. And when you have parallel lines cut by a transversal, you have what's called AIA, alternate interior angles are equal. Alternate means one on each side of the line, that is the transversal. Interior meaning that they are inside the parallel lines, and then they're equal. So alternate interior angles are equal. So this 26 is also 26 down here. Another thing that we have is with this uh, isosceles triangle, since we know the angle up here and these two have to be the same, we can take 180, which is your total angles in a triangle, minus the 26 gives you 154. And since these two have to be equal, we can just divide it by 2 and get 77. So now that we have the 77 and 26, we add those up to get 103, and 103 is vertical to the x. So since it's vertical to the x, vertical angles are equal, so the x equals 103. Moving on to B, here we have another diagram. This involves geometric properties of circles. So when you're dealing with a complicated diagram, it's not what you're looking at, it's what you're looking for. So what you're looking for are those properties that you learned in the geometric properties of circles that you learned, at some time through your IGCSE material. So let me walk you through a few of those. One of those properties is right here with the 17. 17 is an inscribed angle, meaning it's written right on the edge of the circle. And when you have an inscribed angle, the central angle is twice the inscribed angle. Now you say there's no central angle here, but central angles are the same as arcs being these parts out here. So if the inscribed angle, or if the central angle is twice the inscribed angle, it means the arc is also twice the inscribed angle. So if you just multiply the 17 by 2, this little arc right here is 34. This would be the same value as if you had a central angle that corresponded to this. Then, because QP is the diameter, then half the circle is 180 degrees. So 180 minus 34 is 146. And now 146 is what this inscribed angle opens up to. This little angle over here, you follow it through right here to, it's an inscribed angle, and it opens up to this arc 146. So if we divide 146 by 2, we get the 73. Now we're starting to fill in this inner triangle. We have y, which we're looking for. We now have 73. Now we need to find this angle up here. So another property is with this tangent. Tangents to circles are perpendicular to the radius. Well, a diameter includes the radius. So a tangent line to a radius is perpendicular, meaning 90. So 90 minus the 58 gives us 32. Now we have two of the three angles in the triangle. So 180 minus the 32 plus 73 gives us 75. Okay, so y is 75. So let me walk you through that again really quick. Three different properties that you're looking for. One of them being an inscribed angle to either a central angle or an arc. You either divide the central angle by 2 to give you the inscribed, or you multiply the inscribed angle by 2 to get the central angle. And remember, central angles and arcs are the same. So that's one property. Another property that we used is, well, here you could show it. I put it over here. It didn't really come into play that I used it, but a uh, diameter or an inscribed angle that opens to a diameter is 90 degrees. That's why I put this little 90 here. I didn't actually use it, but an inscribed angle that opens to the diameter is 90. Now you could have used that and say, well, it's an inscribed, so if you times it by 2, you get 180. So you could have done that to get the 180 instead of just saying, well, a diameter also gives you 180. That's another way of looking at it. And your 73 times 2 is your 146, or your 146 divided by 2 is your 73. I guess we worked this way to get 73. Then tangent line to diameter is perpendicular, giving your 90. 90 minus 58 is 32. So all of those things are what you're looking for to help you start filling in these values. Notice this was 5 points. So you're not going to get it in just one observation. You're going to have several observations. So you just start working your way around the circle. What is it you're looking for? You're looking for inscribed angles. You're looking for an inscribed angle to a diameter. You're looking for tangent lines that are perpendicular to a radius. All of those things help fill in the circle until you get this inner triangle going, and then you can solve for the y. Moving on to number 3, the probability that Andre cycles to school is r. Write down in terms of r the probability that Andre does not cycle to school. Well, hopefully you remember your probability of not an event is 1 minus the probability of the event. So if the event is r, then not would be 1 minus r. The probability that Benoit does not cycle to school is 1.3 minus r. The probability that both Andre and Benoit do not cycle to school is 0.4. So complete the equation in terms of r. Well, if both of them are not, Andre then for not is 1 minus r, and Benoit for not is 1.3 minus r equals 0.4. That's the equation. Now we need to show that this simplifies into this quadratic. So we multiply our two binomials together, get 1.3 minus 2.3 r plus r squared equals the 0.4. Let's clear our fractions. So we need to move the decimal over one place on all the terms. That gives us 13 minus 23r plus 10r squared. Notice this is an understood 1 in front of the r squared. So when you move the decimal over, you get 10 r squared because it's the coefficient. You don't move it into the r. You're moving the coefficient over. And then over here on the right hand side of the equation, you move the decimal over and get 4. Then we subtract 4 and write our quadratic out. 10r squared minus 23r plus 9 equals 0, which is what they had in the beginning. Now they want us to factor that, solve by factoring. So you've got your quadratic here. So you need to factor both the 10 and the 9. If you have problems factoring quadratics, I have a video for AS level, Pure Maths 1, quadratics. Part 1 is on factoring. It kind of covers different types of factoring, but one of the types is quadratic factoring. Another method that you can use on this if you have trouble with these lead coefficients that you have to factor and the constant at the end and working with both sets of numbers, what you can do is multiply the 10 to the back, make 90 and factor that, but then you have to remember to divide by 10 within those factors. So again, that method is also covered in my video on factoring for AS level math quadratics. But here I factored the front, 1 and 10 and 2 and 5, factored the constant, 3 and 3, 1 and 9. You're looking for a combination that gives you negative 23. So 2 times 9 is 18 plus 5 is 23. Both of them signs are going to be negative. So you're adding two negatives. Okay, so uh, 18 and 5 is what gives you 23. So 2r minus 1 and 5r minus 9. The 2 and the 5 come from right here, the 10. The 1 and 9 come from right here, the 9. They're both signs, because it's positive here means both signs are the same as the front one. So they're both negatives. You can work it out. 2r times 5r is 10r squared. Negative 1 times negative 9 is positive 9. Here's your negative 5. Here's your negative 18, which gives you negative 23. So you're going to have to learn how to deal with those quadratics that have a lead coefficient and make sure that you can do those kinds of factoring. They're a little tricky, but there's a couple different methods of doing it. So when you solve this one here, the front factor, you get 2r equals 1, divide by 2, r equals 1/2. When you solve this one here, you get 5r equals 9, and divide by 5, r equals 9/5. So r equals 1/2 or r equals 9/5. Now remember, these are the algebraic possibilities. Okay. So 4, find the probability that Benoit does not cycle to school. Well, we see that Benoit does not cycle to school is 1.3 minus r. So we need an r. Well, r is right here. Why is it 1/2 and not 9/5? Well, 9/5 is 1.8. You can't have a negative probability. 1.3 minus 1.8 would be negative. Can't have negative probability, so it's got to be the 1/2. 1.3 minus 0.5 is 0.8. So 0.8 is the probability that Benoit does not cycle to school. I hope I'm pronouncing the name right. Looks maybe French, so I'm probably not pronouncing it right, so sorry about that. Number 4a, the equation of a straight line is 2y equals 3x plus 4. Find the gradient. Well, we want to put it in slope-intercept form, so we're going to divide by 2, which gives us y equals 3/2 x plus 2. Now we can see the slope right here is the coefficient to the x, that's 3/2. It's y equals mx plus c form, m is the slope. Moving on to 2, find the coordinates of the point where the line crosses the x-axis. Well, if you're crossing, or sorry, the y-axis, find the coordinates where the line crosses the y-axis. If you're crossing the y-axis, it means your x value equals 0. Plug 0 in, your y value is 2, so you have the coordinates 0, 2 for where it crosses the y-axis. Now we have the diagram shows a straight line. Here's your line. Find the equation of the line. Well, again, we can use y equals mx plus c, where the c is where it crosses the y-axis. So here's your y-axis, it crosses at 6. So there's our plus 6. Then the m is slope. So from the 6 down and over to get back to the line. Notice we can't go down 1 because we don't get back to a grid mark. But we can go down 2 and go over, and we hit a grid, means where it crosses the grid lines, exactly right here. So over, down 2 over 1 means negative 2 over 1, or in other words, the slope is negative 2. So the equation of the line is y equals negative 2x plus 6. Now we want the equation of the line that's perpendicular to L and passes through 9, the 0.93. So perpendicular means our slope is the negative reciprocal. So we take the negative 2 from the line here, then perpendicular will be the negative reciprocal. Change the sign and flip it over. So 1/2 is our new slope for the perpendicular line. So y equals mx plus c. Then we use the 9, 3 for x and y. Solve for c. C is a negative 3/2. and then plug that into the c. So we have y equals 1/2 minus 3, or 1/2 x minus 3/2 is the perpendicular to the line up here. Moving on, A is the 0.85, B is the point -41. Calculate the length of AB. This is just the distance formula where you get y2 minus y1 squared plus x2 minus x1 squared. And the square root of that will give you the hypotenuse, which is the distance. So 1 minus 5 is -4 squared is 16. -4 minus -8 is -12. Squared is 144. 16 and 144 give you 160. And the square root of that, I kind of simplified the radical there. You don't have to, you just plug it in your calculator. Square root of 160 is 12.6 to 3 significant figures. Moving on, part 2 here, or II, find the coordinates of the midpoint of AB. Well, we need our coordinates AB up here. Midpoint is halfway between the x's and halfway between the y's. So x1 plus x2 divided by 2 and y1 plus y2 divided by 2. It's averaging the x's and averaging the y's. So we get 4 over 2, which is 2 for the x coordinate. 5 plus 1 is 6 over 2 is 3. So 2, 3 is the coordinates of the midpoint. Moving on, we have this table of values. This is our graphical solutions type, question type. And you need to fill in these 3 missing coordinates here. So we plug the 0.2 in for the x's. Use your calculator, plug in the 0.2. You should get 2.45 for your y. Plug in 1, you should get 0.25. Plug in the 2, you should get a negative 0.25. So that gives you some calculator practice. 3 points, 1 for each. Then you're going to graph all of those on the graph down here. I'm going to shrink it up here a little bit so you can see the whole graph. And here you see when you plot all those points, you get this kind of smooth curve. You shouldn't have any pointy places. It's a smooth curve. This is the graph here. Then right here, it says on the grid, draw the graph of, we already did that. We completed the table. We drew the graph. Now we move down here to letter C. Use your graph to solve the equation 1 over 2x minus x over 4 equals 1/2. First, check the left to make sure it's the same as the one you just graphed. It is. So the left is the graph you just did. The right is 1/2, meaning we want to draw the line y equals 1/2 and find where those two intersect. Okay, so the graph on the left, or the part on the left of the equation you already graphed. So now we're going to graph the right, y equals 1/2. So that's this right here, y equals 1/2, which is same thing as 0.5. This horizontal line is that graph. Where it intersects this graph, where they're equal to each other, is right here. So you want to follow that down and find this value right here. So notice it's 1, 2, 3, 4, somewhere in there. So you can see I put 0.78. See, this is already 0.5. You actually, sorry, you want to go this way. 0.5, 0.6. 0.6 is 2 spots. 0.7 is 2 spots. 0.8 is 2 spots. So this would be 0.8. So it's between 0.75 and 0.8. So I put 0.78, and notice it allows anything between 0.7 and 0.8. Then on the grid, draw the line y equals 2 minus x. I rearranged it into y equals mx plus b form. Crosses at 2, the y-axis at 2 with a slope of -1. So here I've crossed the y-axis at 2 with a slope of -1, meaning down 1 over 1. Make sure you're paying attention to the scale, because you go by the scale, not by the little boxes. Okay, so you don't go down 2 boxes over 1 box. You go down 2 uh, um, sorry, it's yeah, -1. So you go down, not one, you go down one scale point and over one scale point. Now, it did happen to come out to be down one over one on your box, and that's because your left and your y-axis and x-axis scale are the same on this particular question, but they're not always the same. Your x-axis and y-axis are not always the same scale. So pay attention to your scale, not just the number of boxes. So down one over one, uh, put you here, draw your line through it, and then what it wants you to do is write down where it crosses the graph. Notice it crosses at two places, one right here and the other one all the way down here. So you need to find both of those x coordinates. So right here would be somewhere in here, and this one up here would be somewhere here. You might want to use a straight edge on it so you can see better where it crosses the x-axis. Looking at it with your eyes might make you go cross-eyed trying to look at all these lines. So I put down 0.28 and 2.4, and you can see that they give you a window of 0.27 to 2.28, really small window there, and 2.38 to 2.39. So you have to be quite precise to get the points. Now, show that this can be used, this graph, excuse me, show me that this graph can be used to find the value of root 2. Now, I have to admit, I don't really like the way Cambridge worded this question because it kind of leaves you hanging there. How do you use this to find root 2? You're not really sure what you're supposed to do with it. And basically, they're implying, although to me it's a little vague, they're kind of implying that this root 2 is the root of the graph, meaning where the graph crosses the x-axis. So I don't think the wording is really clear in that regard. But if they, uh, if you solve where this crosses the x-axis, meaning you solve where it's equal to 0, and you add the x over 4 to the other side, you cross multiply, and you solve for x, you do see that x comes out to be plus or minus root 2. And since the domain in our case is in the positive direction, then you only get the root 2. So you can use this to set it equal to 0 and solve for root 2. And what they're telling you is the root 2 is where it crosses the x-axis. And if you take your root 2 on your calculator and you look at where your graph crosses the x-axis, you're pretty much going to get the same value. Okay, root 2 is, I think, 1.4 something, but you can look at it yourself. Then moving on, expand and simplify this binomial expansion here. So x plus 7 times x minus 3, or this, I should say, binomials multiplying each other. So you get x squared plus 4x minus 21. You get plus 7 and minus 3 for the x. So plus 7x minus 3x is 4x, and then minus 21. So that's your quadratic that you get by expanding those binomials. Then for part B, you're factorizing, and you should recognize this. Well, first of all, you need to see what's common to both terms. There's a 5 for the coefficients. You can divide out a 5, and a q squared is common. So look at what's common to both. When you divide out 5, you get 3. When you take out the q squared, they're gone, and you're just left with p squared. On the right, when you divide by 5, you get 5. And when you take out q squared, you're only left with q. At first, I thought it was going to be a difference of squares, but that can't be because we have a cube, and 15 doesn't work as well. So it's actually monomial factoring, just taking out what's common to both. Remember, factoring is dividing, so you want to divide the coefficient. And for exponents, your rule for division of exponents is subtract. So 2 minus 2 and 3 minus 2 for that. On to the second part, you have factoring by grouping. Usually you can just divide it by 2, factor the left and factor the right. Factoring by grouping has 2 successive factorings. So first split it in half. Look what's common on the 2 on the left, which is a 2g. When you factor it out, when you divide out the 2 and the g, you get 2f. And then when you take it from the second one, you get 3h. And then from the right-hand side, there's a 5k common to both. Factor that out. And when you factor out 5k, you get 2f and 3h. Now, to know if you did that right, if what you have left is the same thing on both, you know you're going in the right direction. So since these are the same, you can factor that out because you went from 4 terms, now you're down to 2 terms. Remember, terms are separated by plus or minus, not by multiplication. So these are common to both terms. Factor it out. When you divide it out, you're left with the 2g plus 5k. That is your answer to this II. Now for III, this is a difference of squares. 81 is a 9 squared. And then you have k squared minus m squared. So a difference of squares is 9k plus m times 9k minus m. So this is typical difference of squares. Again, if you have trouble with factoring, go to my AS level quadratics. Part 1 is on factoring. It goes through all these types of factoring if you need to learn your factoring better. Solve the equation. Here's an equation with a fraction in it. So the first thing I'm going to do is eliminate the fraction, multiply everything by 5. That gives you 15x minus 60 plus x plus 2 equals 30. Combine your like terms, gives you 16x plus 2 equals 90 by moving the 60 to the other side. Subtract the 2 gives you 88. Divide by 16 gives you 5.5. So that was pretty straightforward solving. Moving on to number 7, we're dealing with interior angles. Your formula for interior angles for the total number of interior angles or degrees, you have n minus 2 times 180. N being the number of sides of your polygon, minus 2 times 180 will give you the total number of interior degrees. So since this is a pentagon, it has 5 sides. So 5 minus 2 times 180 gives you 3 times 180. There's a total of 540 degrees inside the pentagon. Since it's regular, meaning each corner is the same, so divide by 5, there's 108 degrees for each angle. Okay, so it says show that each interior angle is 108, which we did. Then we move down here. Here's our regular pentagon in a circle. And so if we draw little radii from each vertex to the center, then we divide 108 by 2 to get 54 for each of these corners there because the radii are equal length. So that means the angles across from those radii are equal value. So we have 12 and 12. And where did our 12 come from? Oh, because it says right here the radius is 12. And what it wants us to find is BM. BM is halfway to BC. Okay, BM is halfway to BC. So if we draw these radii here and make this a isosceles triangle, and OM has cut it in half. Remember, a line coming from the center that bisects the chord makes a 90-degree angle. When you draw a line, this is part of geometric properties of circles. When you draw a line from the center to the chord and it bisects the chord, which it does here, then that means it's perpendicular to it. See, notice M is midpoint, so that tells you you're bisecting the chord. So that makes it perpendicular or 90. So now that we have 54 and 90, we can find this BM by our SOHCAHTOA. So cosine of 54 is adjacent over hypotenuse. So BM is the adjacent. Hypotenuse is the 12, which is the radius. So multiply 12 times cosine of 54, and you get 7.05 to 3 significant figures. Now it says OMX and ABX are straight lines. Find BX. So BX here, since both of these are 54, that adds up to 108. And 180 minus 108 is 72 because this is a straight line. So straight line makes 180 minus the 54 and 54 give you what? 72. Now we have 72 and the BM is our 7.05. So we can find BX. Again, over here we had a perpendicular. So this is a straight line, meaning that's perpendicular, meaning we can use SOHCAHTOA. So we can now take cosine of 72. Cosine of 72 is adjacent over hypotenuse. So cosine of 72 is adjacent, which is the BM, over the BX. The adjacent is this side, and the hypotenuse is this side. So cosine of 72 is adjacent over hypotenuse. So the BM is 7.05, but I would recommend that you use the 12 cosine 54 because we rounded this value. You don't want the rounded value because it might throw off your 3 significant figures. So use 12 cosine of 54 over BX equals cosine of 72. Multiply the BX over to here and divide by the cosine of 72. So rearrange your BX so it's over here. Divide by the cosine of 72. Take 12 cosine of 54 divided by cosine of 72. Make sure your calculator is in degree mode since you're using trig functions. You should get 22.8, which is your answer for BX. Now calculate the area of triangle AOX. AOX is this triangle. So we need to find the length AX here. We need to find the length AX. So first of all, since BM is 7.05, all we have to do is multiply that by 2 to get BC, and AB is going to be the same as BC because this is a regular polygon here, regular pentagon. So 7.05 times 2 is 14.1 plus the 22.8, which was the BX part, gives us 36.9, which is AX. So notice we have two sides of this triangle and the angle in between. So we can use the trigonometric formula for area of a triangle. Trigonometric formula for area of a triangle is 1/2 AB sine C, which means any two sides and sine of the angle in between those two sides. So the area equals 1/2 A length 12, B length 36.9, sine of 54 is 179.116 or 179 to 3 significant figures. On to number 8, we've got these two triangles here. The diagram shows two triangles ABD and BCD, and it gives you this information about angles and lengths. Find AB. Well, we have two sides in the included angle. We do not have a pair of angle and side. Notice here's the side, no angle. Here's a side, no angle. Here's an angle, no side. So if you don't have a pair, you have to use the law of cosines, where AB is opposite the angle. So AB squared equals the 12.4 squared. That's the 12.4. And here's our 16.5 squared minus 2 times the 12.4 times the 16.5 times cosine of the angle. This is your law of cosines formula. If you don't know it, you should memorize it, because the law of cosines, uh, not always, but usually shows up on once on every test set. So this is the law of cosines. I learn it as c squared equals a squared plus b squared minus 2ab cosine c. That's the formula I use, and then just plugging the parts into it. We're solving for ab. So as you work through this, make sure that you're careful right here at this step. When you subtract, you cannot subtract these two numbers. Multiplication has to come first. So make sure you multiply this before you subtract. That's where a lot of students make a mistake, is they subtract these two numbers before they multiply, which is incorrect. You multiply these two before you subtract. You get this square root and you get 15.7, three significant figures for your A, B. Now we want to find BC. Well, BC is this length down here. We're given these two angles, so we want to find this third angle. So 180 minus the 50, why did I put 58 plus 95? That's a 53. Okay, that should be, I miswrote this. This should be a 53, not a 58. Should be 53 plus 95, and when you take 180 minus that, you should get 32. Okay, so I don't know why I put 58 down. Should be 53. Then once you have the 32, now you have a pair. In other words, you have a side and an angle. So to find BC, we can now use the law of sines, which is a little bit easier to use than the law of cosines. So 12.4 over sine of 32 will equal BC over sine of 53. Here we have 12.4 over sine of 32 equals BC over sine of 53. And cross multiply, or actually just multiply the sine 53 to the other side. Your BC is by itself. So 12.4 times sine of 53 divided by sine of 32. BC is 18.68, or 18.7 to three significant figures. So again, this 58 should be a 53, but I think I actually did the math right. That should still be 32. I just didn't write the 58 down right. It should be 53. Now down here, we have this sector, and says the sector of a circle has radius of 3.8 and an arc length of 7.7. So our formula for arc length, when we're dealing with degrees, you need to pay attention with arc length and sector area, because there's two different sets of formula. One set of formula is for degrees, the other set of formula is for radians. In IGCSE, they pretty much stick with the degrees, but when we move up to the AS level, it pretty much sticks with radians. So make sure that you pay attention to which formula set you're using. This is in degrees because of the little y to the degree here. Find y. So y degrees out of 360. Arc length is a part of circumference. Circumference is 2 pi r. So here's the r, the 3.8, and we want a fraction of the circumference, and the y degrees out of 360 total is that fraction. You multiply this out and you get 7 points. You set it equal to the 7.7 because that's the actual arc length. Then you solve for y. So multiply the degrees, sine cancels here. You multiply all this by 360 and multiply the 360 to the other side, divide by this 2 pi times 3.8, and you get 116.099 or 116.1 degrees. Remember, when you're solving for degrees, you go to one decimal. Doesn't matter how many significant figures, you go to one decimal point. Okay, so this is your degree formula for arc length that gave you the answer. You're solving for the y. Now calculate the area of the sector. So again, for area, we want the angle over 360, so the 116. Notice I took the 0.099 to be a little bit more accurate. Over 360 degrees, I didn't put the little degree circles. And area is a fraction of a circle. So here's pi r squared, which is area of a circle. The radius is 3.8. Again, remember 3.8 is our radius. And here's our fraction of the circle, 116.099 over 360. Multiply all that out, you get 14.63 or 14.6 to 3 significant figures, because this is area, not degree measurement. Moving on to number 9, 100 students were each asked how much money they spent in 1 week. Here's the frequency table. So you have 16, 38, 39, and 7. Here's your boundaries. 5 students, 5 to 10, 10 to 20, 20 to 30, 30 to 50. Or sorry, M is the amount of money. The 16, 38, 39, and 7 are number of students. Now calculate the estimate of the mean. When you're doing mean on a bound group graph, here's these groupings or boundaries, class boundaries, you find the mid class. So all of these numbers up here are the middle of the class or the middle of the boundary. And so you take the frequency times the mid class value when you are calculating mean. So 16 times the 2.5, 38 times the 7.5, 30 times the 15, 9 times the 25, 7 times the 40, and you add all that up and divide it by 100, which is your total frequency or number of students, and your average then is 12.8. And because we're dealing with money, it's $12.80 is the average amount spent. So 12.8 is 3 significant figures, but since we're dealing with money, we go to 2 decimal points. Now complete the cumulative frequency. So cumulative frequency is just adding up these values. So here 38 plus 16 is 54, 30 plus 54 is 84, and 9 plus 84 is 93, and the 7 plus the 93 is the 100. So that's just 2 points there, finishing off your cumulative frequency. Then they want you to draw the cumulative frequency graph. Remember, when you're drawing cumulative frequency, you draw the cumulative frequency with the upper bound of your class boundaries. So in this case, the 5, 10, 20, 30, and 50 are all the upper boundary. So this implies that 0 is your lower end. So you start at 0, then 16 graphed with 5, 54 graphed with 10, and so on. So here's the 0, here's the 16 graphed with the 5, the 54 is graphed at the 10, so here's the 10, and the 10 with the 54, and then you 84 at the 20. So here at 20, you go up to 84, and you're 93 at the 30. So here's 30, go up to 93, and you're 100 at the 50. And you draw a nice smooth curve. It should have a basic kind of a S shape, a stretched out S. Notice here it kind of curves this way, and then it starts curving the other way, makes kind of a long stretched out S shape. But make sure it's smooth, not, don't make straight lines, make it a little curvy. Then we can go to the questions. Use your cumulative frequency diagram to find an estimate for the median. Median is middle. So out of 100 students, the middle would be 50. Use your straight edge to follow the line across to your graph, and then change your straight edge perpendicular and draw it down to right here. So it's a little less than 10. I put 9.75. They allow 9 to 9.8. Okay. Then find the interquartile range. Well, interquartile range is Q3 minus Q3 minus Q1. So Q3 is 75%. So 75% of 100 is 75. That's this one right here. Follow it over and down, and I put 15.5. The Q1 is 25%. So 25% of 100 is 25. That's this one right here. 25 goes over and down to 6.5. So then take 15.5 minus 6.5, I get 9. They allow you a window from 8.5 to 11.5. Notice these didn't land right on a line. You're kind of in between lines, so you're guessing a little bit. That's why they allow these windows. If you happen to be right on lines, their window's a little smaller. You have to be quite exact. the number of students who spent more than $25. Notice here's your amount, $25. Right here is your 25. More than is this side. So when we follow the line up and back this way, remember the more than is this right-hand side. So you follow it up and over. So we're looking at this top part, not the bottom. So from 100 to 89 is 11. The number of students, and students are people, so you need an integer value. You can't have a decimal with people. So I put 11, and they allow you 10, 11, or 12 is their window. Moving on, the volume of a solid metal sphere is 24,430 cubic centimeters. Calculate the radius of the sphere. Sphere for volume is 4/3 pi r cubed. So set that equal to the volume they gave, 24,430. Divide both sides by 4/3 pi. Use the pi symbol on your calculator. Then take the cube root of both sides. You get 18.0002. To three significant figures would be 18. Remember, zeros in the middle are significant. So the 1, 8, and this first 0 here would be significant. I suppose you probably should put 18.0. I just put 18 here. Looking at it, if we go with significant figures, because it doesn't say to a particular point, probably would be safer to put 18.0 instead of just 18 to make sure you have three significant figures. Then I here says that this sphere is placed in a tank. The tank is cylindrical with a radius of 50, and it's standing on its circular base. Water is poured into the tank up to a depth of 60 centimeters. Find the number of liters of water needed to do that. So our cylinder formula is pi r squared h. Hopefully you remember a cylinder has a circle, that's pi r squared, and then the height gives you the third dimension. So if we plug that in, pi r being 50 squared, and they filled it up to 60 centimeters, that gives you a total of 471,238.898 centimeters cubed of water minus the volume of the sphere, the 24,430, means that the actual water amount that filled in around the sphere was 446,808.898 centimeters cubed. We need to change that to liters. So remember that 1,000 centimeters cubed is equal to 1 liter. So divide this by 1,000. That gives you 446.8. To three significant figures is 447 liters. That's how much water was needed to pour around the sphere to raise the depth up to 60 centimeters. Now we move on to part B. A different tank is cuboid, measuring 1.8 meters by 1.5 meters by 1.2 meters. Water flows from a pipe into this empty tank at a rate of 200 centimeters cube per second. So first, let's find the volume of the cuboid. 1.8 times 1.5 times 1.2 is 3.24 meters cubed. Then, because the volume of rate of the water is in centimeters cubed, let's change that meters cubed over to centimeters cubed. 1 meter equals 100 centimeters. That's one-dimensional. We need to cube it to make it three-dimensional. When you multiply 3.24 times 100 cubed, you get 3,240,000 centimeters cubed. It's flowing in at a rate of 1 second per 200 cubic centimeters. So you divide by 200, and that gives you 16,200 seconds. We want to find the time it takes to fill the tank in hours and minutes. So we take our 16,200 seconds, we divide it by 60 to get 270 minutes, divide it by 60 again to get the number of hours. We see that it's 4.5 hours, which is 4 hours and 30 minutes. Moving on, we have this similarity of these two shapes, looks like waving flags. And we have the areas given of both. We have the width here of 17 centimeters and an unknown width. So the diagrams are said to be mathematically similar shapes, and the width of the larger 17, calculate the width of the smaller shape. So we start with the values that are given, and remember that it's an area, and we want to go from area to length. So area is two-dimensional, it's quadratic, meaning it's square, and we want a linear value, which is one-dimensional. So we want to square root our ratio to get from quadratic or from area down to linear. So this ratio square rooted gives us 0.7353, and then we set that equal to our ratio of length, which is x over 17, and then we just multiply by 17, and this x width is 12.5. Moving on here, I think this is the last question here, and it has these kind of diagrams where you can count the lines and the dots. So notice diagram 1 through diagram 5, and we need to all remember 5 and 6 are actually empty here. So they give you 1 through 4, the information, and they count up the number of lines. So you can see 1, 2, 3, 4 lines, and also the number of dots, 1, 2, 3, 4. So they give that for diagrams 1 through 4. You can count it yourself if you want. And what we need to find is the numbers for diagram 5 and 6. Well, they give you diagram 5, but that's a lot of little lines and dots to count. They don't give you diagram 6. What we want to do is we want to look for patterns. So if we look for number of lines going from diagram to diagram, from diagram 1 to 2, you add 6. From 2 to 3, you add 8. From 3 to 4, you add 10. So you can see a pattern of an increase by an increase of 2 for each one. So from 6 to 8 to 10 to 12 to 14. So from 4 to 5 should be an increase of 12. So 28 plus 12 is 40, and then 40 plus 14 is 54. Now you can double check if you want to count all the lines of diagram 5 to make sure you have 40, which you should. Then for number of dots, from 4 to 8 is plus 4, from 8 to 13 is plus 5, from 13 to 19 is plus 6. So then you're going to have plus 7 and plus 8. So that should give you 26 dots for diagram 5, 34 dots for diagram 6. Again, you can count up the dots just to verify you have 26 dots there. Now it says for diagram N, which is an unknown number, find an expression in terms of N for the number of lines. So we got to find a pattern as how the number with respect to diagram translates into the number of small lines. We need to come up with an expression in N being the number for the diagram. Now, again, this is kind of identifying patterns. What I do, and this is not something that will work every single time, but it is one of the things that I look for, especially when I'm trying to compare two sets of numbers, the diagram with a set of values. I take one of the larger diagram numbers to represent my N. Don't take the smaller ones because it can throw you off track. You want to take a larger one. I'm going to take 5 because 5 is easier to work with than 6. So what I will do is I'll first start with an exponent, then I'll work to multiplication, and then I'll work with add or subtract. So I start with the exponent. What exponent can my 5 be raised to get me close to 40? 5 to the 1 power is 5, 5 squared is 25, 5 cubed is 125. 125 is over. So we want 5 squared. So that's, remember 5 represents my N. So N squared, 5 squared is 25. And if I take that out, that leaves me with 15. 40 minus 25 is 15. Now that I've done exponent, I move to multiply. What can I multiply my 5 by to get 15? Well, it works out to be exactly times 3. So that's plus 3n. If I were still left over like 1 or 2, that would be my addition on the end here, okay? Or, it could be a subtraction, depending on whether you were close by 1 or 2. But we fit it exactly. 5 times 3 is 15. Now go back and try it with another one. Let's try it with 2. 2 squared is 4, and 2 times 3 is 6. 4 and 6 does give us 10. So it works for all of these. This expression, n squared plus 3n. So that's what I do. Doesn't work all the time, but it does work, every once in a while. Now for C, diagram R has 10,300 small lines. Here's the formula we created for our value. So n squared plus 3n has to equal 10,300 for this diagram. N is going to be the rth diagram. So in this case, n and r are the same thing. I put it as n, but actually it's r being the nth term. So r squared plus 3r equals 10,300 lines. And move that to the other side, and you have a quadratic. Now, you can use the quadratic formula. In fact, most of you are probably familiar with the quadratic formula. You can use that. But just for fun, I tried the Po-Shen-Lee method. And if you don't know what that is, I have a video on that. Again, AS level quadratics. I think it's part 3B, if I remember right, on the Po-Shen-Lee method. He was a person from Carnegie Mellon University who developed this method. And what he does is he starts, this is a parabola. He starts from the vertex. The vertex is negative b over 2a. And since our a is a 1, it's negative b over 2. So negative 3 halves. That's the x-coordinate of the vertex. And then the distance from the vertex to either side of your parabola, I use the letter z. So remember, the vertex is right in the middle on the axis of symmetry. So if you go an unknown length over to the left and an unknown length over to the right, we call that z. So plus z would actually take you to the right, minus z would take you to the left. That actually would be the roots of where your parabola crosses the x-axis, and that will equal the c value. The c value being your negative 10,300. Why do the roots equal that? Because when you factor the c value to get your two numbers, and when you multiply your two roots together, it gives you that c value. Okay. So again, if you want to understand it better, watch that video. I explain it and give examples on it. So right here, I'm just using the method. Then you multiply out this binomials here. You get 9/4 minus z squared equals the negative 10,300. Again, if you don't understand this method, then just use your quadratic formula. You can plug it right in on your calculator. Then if you solve for z squared, get the z squared positive and move your 10,300 over, you get 10,302.25. Square root both sides, you get z equals plus or minus 101.5. Again, we're dealing with positive values, so you're only going to use the positive 101.5, and that's the z. So the z goes from your vertex. So negative 3 halves plus the 101.5 gives you exactly 100. If you use your quadratic formula, you're going to find that the positive number is 100, and you're going to throw out the other one because you can't have negative values with these diagrams. Going on, the number of dots. Now pay attention, because up here we're dealing with lines. Now we're dealing with dots. So we're dealing with this lower row of numbers. Says the number of dots is given by this expression, an squared plus bn plus 1. Again, n is the number of diagram that you're on. Find the value of a and b. Well, since you have a lot of diagrams to choose from, you can pick whichever diagram you want. Since we're dealing with numbers, I prefer to deal with smaller numbers, so I use diagram 1 and 2 with number of dots of 4 and 8. So if you pick diagram 1, 1 being the n, you get a plus b plus 1 equals 4. That was the number of dots. If you pick diagram 2, 2 being the n, you get 4a plus 2b plus 1 equals 8. Again, 8 being the number of dots when n equals 2. So now we have simultaneous equations, and we're solving for the a and b. So in other words, just pick whatever two diagrams you want so that you create simultaneous equations. Now we move the 1 to the other side, so a plus b equals 3. Move the 1 to the other side, 4a plus 2b equals 7. So we want to come up, I chose to use elimination, so I multiply this top one by 2 and just write it underneath. So I get 2a plus 2b equals 6. Now the b's have the same coefficient, so I use elimination by subtracting. So I get 2a, the b's cancel, equals 1, a equals 1/2. Plug the 1/2 back in, so I plug it into this first one here, 1/2 b, 1/2 plus b equals 3. Subtract 1/2, b equals 6/2, which is your 3, minus the 1/2 is 5/2. You can do it on your calculator. I did it with fractions. So a is 1/2, b is 5/2. And there we are. We're at the end of this paper 42 from May, June 2019, year 19, and the paper 42. So I hope that helps you learn these different question types, keep working at it, keep focusing on the mental part of how to set up the question. Again, as always, thank you for joining me and hope to see you again next time.